Building an AI agent that can operate in the real world means connecting it to live, complex data. You need it to pull transactions from Stripe, check customer records in HubSpot, and post updates to Slack, handling all these inputs simultaneously. The Model Context Protocol, or MCP, was created to standardize the physical connection between these platforms and the AI. It provides a clean, universal pipe for the data to travel through. But an open pipe introduces a secondary hazard known as context starvation. This happens when we successfully feed the AI raw data, but strip away the surrounding operational rules required to understand it. Without those rules, the AI has no idea what to do with the numbers it receives. It has to guess. And when an AI model guesses to fill in missing context, it hallucinates. Securely connecting an AI to an API is a solved networking problem. The actual failure point is forcing an autonomous machine to interpret ambiguous data on its own. MVC architecture moves data from a database through a controller, rendering a web page for humans. If an AI intercepts the pipeline, the interface drops away, leaving raw JSON like amount cents 45,000. Logic breaks down. Dollars or cents? What is the correct next billing step? A human user navigates that kind of ambiguity by using outside domain knowledge. If a number looks wrong, we know how to adjust. AI models simply can't perform that leap. Treating an autonomous agent like a human web browser is why these pipelines fail. It's the reason we see unpredictable behavior in production. We fix this by replacing the human-centric view layer with a structure built for machines. This is the Model View Agent, or MVA pattern, and it relies on a central hub called the presenter. The presenter acts as a deterministic perception layer. It intercepts the raw data from the API and shapes it into a specific format before the AI ever sees it. This creates a structured perception package. The presenter wraps raw data in strict validation boundaries, attaches domain rules, and formats UI blocks. Most importantly, it adds affordances, data-driven hints telling the AI exactly which authorized actions to take next. The MVA architecture eliminates the need for the model to guess. It hands the agent a precise, localized user manual for every single data interaction. Building a custom perception layer like this usually requires significant engineering resources. Developers have to spend months creating the infrastructure to support validation and routing at scale. Vinkius removes that barrier. It is a managed MCP gateway that utilizes this MVA structure across its entire ecosystem. The platform hosts over 2,600 ready-to-use MCP servers. Each one is pre-configured to standardize its respective API into the agent-readable MVA format. You can deploy with a single click to a server-sent events endpoint. No Docker containers to manage, no complex CORS configurations, and no infrastructure to maintain. Vinkius turns a complex agent architecture into an instant, universally compatible utility. Because the data arrives with its own structural rules, you no longer have to write massive global system prompts to explain every new API to your agent. This approach works across any use case. Whether the agent is pulling NASA satellite data, Shopify inventory, or live Formula One telemetry, the raw feeds are converted into identical, reliable MVA packages. Since it uses the open MCP standard, this structured data is compatible with any client, from Claude Code and Cursor to enterprise applications. Resolving the hallucination problem isn't about tweaking the prompt, it's about changing how we format the data itself. Vinkius provides the managed infrastructure to implement this architecture today. Stop starving your AI of context and